coil, so I can show you that from the button we have the primary coil, and you are able to select 5 or 4 windings.
Yes.
And on the other side you have the secondary coil.
Yes.
And this is an air transformer. That means we have no iron to lead the magnetic flux.
Yes.
It's only in the spreading fields of the magnetic flux. And then we have the connections of the secondary coil, and the primary coil is the connection in the center, and here the so-called earthing line. The connection in the center is connected with the antenna, and the earthing line is normally connected to the earth. Tesla was using, but Tesla, and this is one difference to the original Tesla patent, Tesla was using very high voltage, about 60,000 volt, and we are working only with 2 volt for the LED that they shine, as you can see here, 2 LEDs, so that we have problems to use the earthing or the earth as a connection between transmitter and receiver. We are using only a cable, and in this cable here, in this cable connection, the currents are floating, and this is the connection or the line back, because the whole system is acting as a resonant circuit, an oscillating circuit with a frequency. And look, when the lamps at the receiver are shining,
blinking.
And here you see that they are shining. That means now energy is received at the receiver side, so that we can try to find out what the properties are. If I switch off the receiver, so that is because I disconnected, then the lamps at the transmitter side, they still are on, but the others are off. If I switch them on again, you see that the transmitter doesn't feel whether they are on or off. That means this is a special property we know from radio signals, that the transmitter of a radio station doesn't feel whether the receivers are switched on or off. That means it looks like a Hertzian wave. Let's try another proof. I try to shield it with my hand, the receiver, and you see that I'm able to shield the signal, and the lamps go out. This shieldable by a Faraday cage is typical for the electromagnetic wave. So that we can say this has to be the electromagnetic wave we have found at 4.6 or 4.7, let me say, megahertz.
Which everybody is used to, that we learn in school, nothing special about it.
But we are able to prove this. If you want to prove it more correct, you have this possibility to change the jumpers from LED to DC. Then you have this rectifier. You can use a standard multimeter, or you change to AC. Then you have 100 ohm load, or you disconnect it and use an oscillograph. This would be the best solution, to use an oscillograph, because it's most direct and most correct, and then you are able to measure the current and the voltage and the phase in between. Because we know that electromagnetic waves have zero. The angle between electric and magnetic field pointer are zero. And if it is zero and you are able to prove it, this is a much better proof that this is exactly the electromagnetic wave. Well, it's a bit difficult. I have not an oscillograph with me, and this is for this interview, because we are now in Sweden, and I have it only for these conferences. I showed it some days before at Pier's conference, Progress in Electromagnetic Research it's called, and it is organized by the MIT in Boston in America. And this time this conference was in Sweden, in Stockholm, so I could show this experiment. And now I reproduce it. I show you again what I have shown on the conference, and this is now exactly the electromagnetic wave. We have to remark this special frequency, 6.7 megahertz. Now we go up again and we switch on, and you see that the lights at the receiver side go out, at the transmitter side they are still on. And let's have a look whether we find another resonant frequency where they shine again, and you will see now they are shining again. And I tune where the maximum is, and here is absolutely the maximum. So what we have reached is a situation where the lamps are shining very bright, and if I try to shield them, it's absolutely impossible. And
Could you please shield again? I
try to shield it. I try to shield it with my hands.
Nothing
happens. And what we see as well is that the lamps, wait a minute, here at the transmitter side, they go out at the while they are shining at the receiver side. And if I switch off the receiver, the lamps at the transmitter side, they go on. Oh, sorry. So I switch it on and off and off, and you see always, if the receiver is on, the transmitter is off. The receiver is off, the transmitter is on. What does this mean? This means that here, with this at 7.7 megahertz, we have a resonance, another resonance where the properties are totally different. And it means that the transmitter feels if the receiver is on. So that the radio station could know how many people are listening, so that they can get the money directly, you see, from those who are listening. Well, this is a totally different wave. It has other properties, another resonant frequency, and
you couldn't shield it.
I can't shield it. And if you use an oscillograph and look exactly what the current and voltage what is different, then you find out that there is a phase angle in between of about 90 degrees. And this is typical for the near field of an antenna, and this near field of an antenna, here I'm in the near field, is typical for the scalar wave.
As you told earlier, when Tesla did it with 42 kilometers in distance, and he got light bulbs to show light without a cable, there was an over-unity effect also.
Yes.
Is it in this kit here as well?
Yeah, this is possible, but you see that we need some sources and...
well, okay, that's a secondary question, but in principle it's interesting.
If they are available, then these over-unity effect could happen. And
you can calculate it with this already also?
Yes, it is possible. If you can't do the experiment with the lamps, because the lamps only indicate what the voltage is doing, that the voltage now at the receiver side is higher than at the transmitter side. But if you are using an oscillograph, I have some results here in my book, such as from the Nottingham University, where they have measured the currents and the voltage and have found out about more than 500% efficiency. Or another colleague who has even get more, it is from New Zealand, he has measured at very, very low frequency, low amplitude, at only some milliwatt, but the input power was 0.5 milliwatt, and the output was more than 6 milliwatt, so that the efficiency was more than 1000%. Well, this is what they have measured, and you see, the more power you have, the less the efficiency will be, because if you have an open system, and the open system is able to interact with the environment. This is what Tesla described 100 years before. If there is any source in our environment, which is usable, which could go into resonance with our system and will be collected by the receiver in addition to the energy from the transmitter, then let me say if you have about 10 milliwatt which are available, we even talk about energy harvesting. So this is very much in use of today, and the industry is looking for energy harvesting. This is an energy harvester, and if there are 10 milliwatt, and if I use this system for 100 milliwatt, I transmit 100 milliwatt, then the over unity will be only 110%, no more. But if I transmit only 1 milliwatt and 10 milliwatt are available from the environment, then I have an amplification of more than 10, that means 1000% efficiency. So if you reduce the power, you have more over unity than if you accelerate, because most of them say if I accelerate this effect and if I get more power, I can use it for as well for 10 watt or so. If I would have 1000% at 10 watt, then I would have 100 watt. So this would be a lot of power, but this is not true. In reality, if you reproduce this experiment, you will very quickly find out that it is the effect is more if you reduce the power.
Yeah.
We say if you have about 10 milliwatt which are available, we even talk about energy harvesting. So this is very much in use of today, and the industry is looking for energy harvesting. This is an energy harvester, and if there are 10 milliwatt, and if I use this system for 100 milliwatt, I transmit 100 milliwatt, then the over unity will be only 110%, no more. But if I transmit only 1 milliwatt and 10 milliwatt are available from the environment, then I have an amplification of more than 10, that means 1000% efficiency. So if you reduce the power, you have more over unity than if you accelerate, because most of them say if I accelerate this effect and if I get more power, I can use it for as well for 10 watt or so. If I would have 1000% at 10 watt, then I would have 100 watt. So this would be a lot of power, but this is not true. In reality, if you reproduce this experiment, you will very quickly find out that it is the effect is more if you reduce the power.
Yeah. And one thing to make it clear for the audience, this shows when you send a scalar wave to this receiver that you transmit electric energy.
Yes, it is an electric wave, because this from ball to ball, this is like a capacitor. A ball capacitor. That means that the electric field line always goes from electrode to electrode, and if it is propagating, the wave which is produced is propagating in that direction, it is a longitudinal wave. we talk about longitudinal waves if the propagation is in the direction of a field pointer. And this is why this longitudinal wave has these properties, and we have now detected by this experimental setup.
And you had some ideas that the technology we use today to transport electricity is very stupid, because you lose a lot, and this way to transport electricity would be much more clever.
Yes, well, the systems of today, I think you think about the RFID technology of radio frequencies.
When I get the electricity here to the house, it's coming from a cable.
Yeah.
But here we can see we can transmit without cable and save much more, you say.
Reproduction of Tesla, and he was the developer of the electric one.
Yes.
And this is why till this time we have in internet only two descriptions about the electromagnetic wave and about the electric scalar wave, Hertz and Tesla, and I have found out the third one and have developed it, derived it, and described it, and now I show that this is usable as well if you for biological effect, the magnetic scalar wave. But you can use this system as well in addition, in combination with a magnetic scalar wave, because at the top of the ball of the antenna we have a maximum of the electric field strength, and you are able to measure all along the coil and all along the line. You find out where the minimum of the electric field strength is, but the magnetic field strength is just the opposite. So it is on top 0, and it has a maximum at that point where I have put the excitation or the primary coil on the button.
And that's why medicines have put medical products on that, and then
they always have to put the products on this point where this coil is on the other side, because here is the maximum of the magnetic field point. So this is what we have measured, you see, and found out that there is the maximum of the magnetic field, and the magnetic field is the one who is accelerating the electrons in such a ring antenna, like benzene ring. Then they are moving, and then they are accelerated, and then they transport the biological information to the coil, to the magnetic fields, and the magnetic fields are involved with the electric fields, so that we get a wave, an electric wave, which is carrying the magnetic wave and the information of the magnetic wave. If they start sending, they give this information, they produce a magnetic wave by themselves, and they give their information to this magnetic wave, which is magnetic scalar wave, yes, which is running into the direction of the magnetic field pointer, and now it becomes a transmitter. So these ring systems are receiver,
and
transmitter, and storage device. They have all these properties we need for communication, you see.
And the biochemists don't say that. They don't think about it.
Well, Kekulé has shown that these electrons are not fixed to the atoms, but that's all. This is what they know. But you know that the organic chemistry, if you compare it with the inorganic chemistry, you see that the organic chemistry always has these ring systems. That means that the organic chemistry is using it for transmission of information and energy.
Is this a kind of Möbius coil?
No.
That's something else.
It's a standard. It's standard physics. If you have a coil, a standard coil, you know that if the electrons are moved because I switch on the current, then we get a magnetic field which is perpendicular. This is standard physics. New is that these things are used in this way, and that they have not only the possibility to be a transmitter as well as receiver and storage. And this is memory effect. These three things in biological systems, this is new. So now I understand the information, how it is stored in these rings. And it's not. These are not benzene rings, but pyrimidine rings. But this is a ring system. Well, we have different ring systems in biology, but it's important to understand that organic chemistry is working with this system. Well, the electric field pointer has to show just in the direction of these rings. If this happens, the field pointer is oscillating. You may say it's like a like a clock. If you take the clock and you have the sign of the minutes, and if you put the sign of the seconds on the top of it, and it is moving like this, and then the movement is like this. So
Two movements combined.
Yes, two movements combined, and if you have a chance to transport this as a vortex in one direction, you are able to transport the information in that direction. So what I have done is I have produced this picture. This is very well known